Okay, Advanced Algebra 2. This is Mr. Clendenin, and welcome to Mr. Patterson's class if you're here watching this. Yesterday, Mr. Patterson walked you through something called a sequence, which is, in layman's terms, a list of numbers that follows a certain pattern. And you had different kind of patterns yesterday that they followed. Some are pretty easy to see. Some you got to look a little bit to figure them out. Today we're going to look at one specific type of a sequence, and that is a sequence called the arithmetic sequence, and that is simply when you add or subtract a constant value. Okay, so you should be able to figure it out by eyeballing the sequences, but I'll show you a way to figure out that what for sure is going on also. But if we look at this first example here, 3, 8, 13, and 23. First off, does everybody know what that dot means at the end of a list? It means that it continues on with the same pattern. So whatever pattern you see, it will continue on forever. Okay, so we look at this sequence and we look from left to right. You always look from left to right, and we try to figure out what's going on. So take a look at that and see if you can figure out what's happening there. You're adding 5. Is that what you came up with? Okay, if you didn't, what you can do is take any number in your list, and by the way, that's called the common difference. We'll get to that more in a second. That's called the common difference. But an easy way to figure out that common difference, or a surefire way to figure out that common difference, is to take any number in your list and subtract the number in front of it. So if you do 8 minus 3, or 13 minus 8, or 18 minus 13, or 23 minus 18, all of them give you 5 for an answer. So take any number in your list and subtract the number in front. And of course, you can't do that with the first number because it doesn't have a number in front of it. Okay? But that's a surefire way to figure out what your common difference is, your D value. Now, that D value, yesterday, Mr. Patterson talked about how you can reference each of these numbers in your list by what position they fall in. So in other words, 3 is in the first position, 8 is in the second position, 13, third position, and so on. All right, but now let's think about that in relationship to what we were doing. We were adding 5. Okay, we added 5 all the way across this list to find each of the successive numbers. Okay, but think about it this way. Start off with this 3. How many 5s did you add to get the 3? Well, you didn't add any of them. It's the first number in line, and you added 0 5. So let's make a little list down here. And this would be how many times we added 5. That says how many times, let me rewrite that, how many times we added 5. Okay. How many times 8 is the second number in line? How many times did you add 5 to get to that? Well, you started 3, you added 1 5. The third number is 13. How many 5s did you add? If you start at 3, you add 5 to get to 8, and you add 5 to get to 13. So you added 2 5s. You seen a pattern with this yet? 18 is the fourth number. How many times did you add 5? There they are right there. 3 times. You didn't add 1 from 13. You got to think about starting at 3. From 3, how many times do you add 5? 3 times. 23 is the fifth number. Starting at 3, how many times do you add 5? Let's count them here. 1, 2, 3, 4. You add 4 times. So look at the position number and look at how many 5s you added. What always happens? It's always 1 less than the position. And your position, the variable that represents position, is n. Okay? So how would we write 1 less than that position? We would write n minus 1. So keep that in mind. And I always simply say to myself, here's the way I say to myself. I say, okay, I got this 18. How do I get to this 18? I start at 3, and I add 3 5s. That's kind of how I think about it in my head. Always start at 3. Start at 3 and add 3 5s to get to my 18. Okay, that's going to be important here. So with that in mind, we could generalize our arithmetic sequences into this equation. A sub n is any number in our list. Okay, so what do we have? We had 3, 8, 13, 18, 23, blah, blah, blah. Way out here somewhere is a to the n. It's some number in our list that we don't know. How do you get there? Well, you always have to start at your first number in line. So we start at a sub 1. Then what do? Well, we add 5s. Okay, well, we call that the common difference, d. How many do we add? Well, we just saw, if we wanted to get to that 18, which is in the 4th position, we added 3 5s. So it was n minus 1. We added n minus 1 5s. So if we want to get to any number in our line, we just kind of follow that pattern in our head. So let's say we want to go to the 37th number in line. What would we do? Well, we have to start somewhere. We start at the first number, 5. Then what do we start doing? We start doing whatever D says we do. It says we start subtracting 3. How many of them will we subtract? Well, if we're going to the 37th number in line, we will subtract 37 minus 1, or 36 of them. Okay. And let's do the math now. So the 37th number would be 5 plus 36 negative 3s. And what is 36 negative 3s? Negative 108. So we find out that the 37th number is negative 105. Oops, can you see that? The 37th number is negative 105. Now, which brings up another point. If we are subtracting, which we are, that's what D says we do, we subtract 3. Eventually, we'll subtract the 3 enough times that we'll get to the negative numbers, and we have. We're way down at negative 105. Okay. Oh, I forgot I had animations. So there we go. The 37 is the n. That's the position. Of course, a sub 1 is 5. D is 3. We plug those in. There we go. We'll do the work here. Getting a notification about an email. Get rid of that. And there we go. We get negative 103. Okay. So the key is, again, you always start at your first number. Then you start doing whatever it tells you to do. That's your D, minus 3. First one was an add 5. But how many times do we do it? That's this n minus 1. You do it one less than what the position is you're going to. We were going to the 37th position, so that means we would have subtracted 3 36 times. Okay? So let's say we want to find the first number in our list. Find a sub 1. If we know the 30th number is 93. Now, when you know this, a sub 30 equals 93. Remember that's 2 pieces of info. That's 2 things. That is a number that you will see in your list. That's a number that's in my list. I will see a 93 eventually in my list. And it also tells you where you see it at. Where will you see the 93? You see it in the 30th spot. The 30, or to say to yourself, the 30th number in my list is 93. So just remember that that's 2 pieces of information. So when we go fill in our formula, the 30, if you can see that green, the 30 is your n. It's the position you're in. The 93 is the number you see. That goes over here where a sub n is. Okay. And of course the D is 3. So what are we doing here? We're adding 3. We are adding 3 as we go. Now real quickly before I fill in the rest of this, if I'm going to the 30th number, how many 3s will I add? Hopefully you said 29. But if we fill in all these positions now, you should get an equation that looks like that. And then we just, once we get everything filled in the right spots, make sure you got your 30 and your 93 in the right spots. The number goes over here. The position goes right there. Then we just do the math. And it'll be 29 times 3, which is 87. Subtract my 87, and my first number in line is 6. Okay. All right, I got one more example, and then we'll be done with this video. All right, this time we want to find D. So let's we're going to figure out what we're adding or subtracting. Right now we don't know. If A sub 1 is negative 27, and the 18th number is 92. So here's your equation. Why don't you, before I pop it up there, why don't you fill in every piece of that formula that you can. Press pause if you need to. Well, of course, we should know, or hopefully you got that equation there. The first number line only has one spot it can go, so that's where our negative 27 goes. The big thing here is, how did you handle this piece of information? Remember, there's two pieces in one. It's the 18th number that's in. That's where my 18 goes. Is 92. That's where my 92 goes. And what I say to myself is, how do I get to 92? Start at negative 27, and I'll start adding my D values, which I don't know, or subtracting D, whatever it turns out to be. How many times do I do that? 17 times, 18 minus 1. Well, when we get it all filled in, we can do the math. All right, remember here, you will add your 27 to the other side, get 119, and divide by 17. We find out that D equals 7, which means we were adding 7 as we go. Now we could have figured out that we were adding in the beginning. If our first number is negative and then we go 18 numbers out and we got a positive 92, we had to add because it got bigger. Okay, so that's just a little look at something called an arithmetic sequence. There's 3 examples there. Now here are 3 homework problems that follow along with the examples, so you should be able to find an example in the notes that matches up with each of these homework problems to help you work through them. Okay, post your pictures in Mr. Patterson's classroom classwork tab and in Mr. Clendenin's classwork tab, and we'll see you tomorrow.